Well, this is the spacecraft, the first to interstellar space. We made it. But it could be another few months, it could be another few years, but it's probably not much longer than that. We travel 1 billion miles every 3 years.
The Earth, though vast and stunning, pales in comparison to the vastness of the universe. As human technology advanced and enabled us to send rockets and satellites into space, our curiosity about the universe's mysteries became insatiable. Now, with the Voyager spacecraft continuously transmitting data back to us, a recent message from it carries a foreboding warning that could potentially reshape our understanding of the cosmos. So in this video, we will delve into the wealth of information the Voyager has gathered so far, dissect the alarming message it has sent, and contemplate the profound implications it might hold for the future. For nearly 50 years, the Voyager missions have been at the forefront of space exploration, providing us with priceless insights into the enigmas of our solar system. It's remarkable to think that these missions, initially not designed for such longevity, have delivered such an abundance of knowledge. The story behind the Voyager program's inception is truly captivating. Launched in 1977, Voyager 1 and Voyager 2 had the primary goal of studying Jupiter and Saturn. But what unfolded exceeded all expectations. Both Voyager spacecraft are equipped with 3.7-meter radio dishes and 16 thrusters for adjusting their orientation and pointing their dishes toward Earth. They rely on hydrazine fuel for propulsion and plutonium-fueled thermoelectric generators to power their electronic components. Each carries 11 scientific instruments, half of which were primarily designed for planetary exploration and have since been deactivated. The ambitious grand tour of the 4 outer planets has transformed into a monumental achievement in human space exploration. Voyager 2 accomplished historic close encounters with Uranus in 1986 and Neptune in 1989, becoming the first spacecraft to do so. Meanwhile, Voyager 1, a few months ahead in its journey, conducted close flybys of Jupiter in 1979 and Saturn in 1980. It has since ventured farther from Earth than any other artificial object, solidifying its status as a space pioneer. While Voyager 2 still operates 5 scientific instruments, Voyager 1 currently utilizes only 4. But both remain vital in collecting invaluable data from the depths of space. Today, these 2 spacecrafts continue their odyssey beyond the influence of the Sun, voyaging into interstellar space while continuously transmitting vital information about the cosmic environment back to Earth. In 2013, NASA made a significant announcement. Voyager 1 had successfully traversed the boundary separating our solar system from interstellar space. Interstellar space, as the name suggests, lies between stars and is characterized by the absence of the continuous flow of particles and magnetic fields emanating from our Sun. Voyager 2, following suit, entered interstellar space in 2018 when it was positioned approximately 17.7 billion kilometers from the Sun. Remarkably, the Voyager spacecraft stand as the sole explorers to have ventured into this distant realm, shedding light on the interactions between the interstellar medium and the solar wind, the constant stream of charged particles emitted by the Sun. Additionally, they've provided invaluable insights into the heliosphere, a protective bubble enveloping our solar system. The heliosphere is formed by the solar wind and is constantly shaped and influenced by interstellar conditions. The precise border demarcating our solar system, where the solar wind yields to interstellar space, is termed the heliopause. These Voyager missions have enriched our understanding of interstellar space, revealing intriguing facts, such as the heightened intensity of cosmic rays beyond the heliopause, which is roughly 3 times greater than within the heliosphere. Scientists have integrated Voyager's discoveries with data from subsequent missions to create a more comprehensive understanding of our Sun and the intricate interactions between the heliosphere and interstellar space, as reported by NASA. Last year, scientists made a fascinating revelation about Voyager 1. They disclosed that this spacecraft had captured a peculiar humming sound, which was associated with waves detected in minute traces of gas present in the nearly empty expanse of interstellar space. Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., emphasized that the Voyager missions have played a pivotal role in furnishing valuable insights into the Sun and its extensive influence across our solar system. She underscored that over the span of 45 years, these missions have been instrumental in advancing our comprehension of the Sun's dynamics in ways that no other spacecraft could achieve. Both Voyager spacecrafts are powered by plutonium-based thermoelectric generators, a type of power system that relies on the heat produced by decaying plutonium to generate electricity. As the plutonium decays, the heat output diminishes, and this results in a decrease in power supply for the Voyagers. To counter this decline, NASA's team implemented measures like deactivating non-essential systems and even some initially deemed essential ones. This included heaters designed to shield the still functioning instruments from the extreme cold of space. Remarkably, despite these power-saving measures, NASA reports that all 5 instruments for which heaters were turned off in 2019 are still operational. This resilience has left NASA scientists perplexed, as they are still grappling with how the Voyagers managed to function in temperatures significantly lower than what they were originally designed for. In the outer reaches of the solar system, scientists have observed an intriguing phenomenon related to the heliopause, which marks the boundary between the heliosphere, the region influenced by the Sun, and the interstellar medium. What's unusual is that the heliopause seems to exhibit irregularities and form atypical angles in a manner that wasn't anticipated. While the idea of the heliopause's shape changing is not entirely novel, researchers have, over the past decade, established that it is a dynamic and evolving boundary. This understanding has been derived from data gathered by the Voyager 1 and Voyager 2 spacecraft, which ventured beyond the heliosphere, as well as observations made by NASA's Interstellar Boundary Explorer, IBEX satellite. The IBEX satellite specializes in studying energetic neutral atoms, ENAs, produced when solar winds interact with the interstellar medium. Eric Zernstein, a space physicist at Princeton University, explained the Voyager spacecraft provide the only direct in situ measurements of the locations of these boundaries, but only at one point in space and time. To complement this data, scientists have harnessed the insights provided by IBEX to create models that predict how the heliopause may transform in the future. In essence, the boundary is in a state of constant flux, shaped by the intricate interplay between the solar winds emanating from the Sun and the surrounding interstellar medium. However, recent research focused on the heliopause has unearthed data that challenges previous understandings. IBEX recorded an increase in the brightness of ENAs over several months in 2014, suggesting asymmetries within the heliopause. Subsequent analysis revealed that these asymmetries did not align with existing models, adding a layer of complexity to our understanding of this boundary region. Additionally, scientists made a noteworthy observation regarding the heliopause by examining data gathered from Voyager 1 and Voyager 2. This observation sheds light on why there was a substantial time gap between the two spacecraft's entry into interstellar space, occurring in 2012 and 2018 respectively. The heliopause displayed significant movement within a relatively short time frame, providing an explanation for this discrepancy. However, this movement contradicts existing theories about the boundary. Researchers have characterized these disparities as intriguing and potentially controversial in an article published in the journal Nature Astronomy. To delve deeper into this mystery, they plan to continue studying the heliopause with the hope of gaining further insights from NASA's upcoming Interstellar Mapping and Acceleration Probe. This advanced satellite is equipped to detect energetic neutral atoms, ENAs, and is scheduled to launch in 2025, as noted by Zernstein. Until then, we can only speculate about the peculiar occurrences unfolding in the enigmatic depths of the solar system. Additionally, in mid-May of the previous year, Voyager 1 experienced an anomaly with its onboard system called the Attitude Articulation and Control System, AACS. The AACS is responsible for maintaining the spacecraft's high-gain antennas' alignment with Earth, enabling data transmission. Instead of the customary health and status reports, Voyager 1 began transmitting perplexing data that resembled nonsensical patterns. It seemed as though the spacecraft had developed a condition akin to electronic aphasia, which impairs coherent communication. This data was either randomly generated or didn't correspond to any recognizable state. NASA acknowledged this unusual behavior, stating that the AACS could be implying an unknown state. What confounded engineers even more was that despite these strange status reports, Voyager 1 appeared to be functioning well. Its radio signals remained robust and steady, suggesting that the antenna was still accurately pointed at Earth, contrary to what the AACS data indicated. Additionally, the spacecraft's scientific instruments continued to collect and transmit data without interruption. Remarkably, the anomaly in the AACS did not trigger the fault prevention system, designed to place the spacecraft in safe mode in response to glitches or irregularities. Fortunately, NASA's experts were able to diagnose and resolve the issue with the AACS. They determined that the AACS had started transmitting telemetry data through an onboard computer that had ceased functioning many years ago. To rectify the problem, NASA engineers simply instructed the AACS to utilize the operational computer for data transmission, as the defunct computer had corrupted all outgoing data. The next step in this process involves identifying what triggered the AACS to switch systems in the first place. NASA suspects that the system may have received an erroneous command from another onboard computer. While this anomaly doesn't currently pose a significant threat to Voyager 1's safety, pinpointing and rectifying the root cause is essential to prevent future anomalies. In the vast and challenging realm of interstellar space, Voyager 1 has been a trailblazer, venturing beyond the protective shield of our Sun's magnetic field for over a decade. It's a hostile environment filled with high-energy particles and cosmic radiation bombarding the spacecraft from all directions. Despite these adversities, Voyager 1 has persevered, continuously delivering invaluable data and insights into the mysterious depths of deep space. What are your thoughts on the Voyager mission and its remarkable discoveries? Feel free to share your thoughts in the comments below. And if you enjoyed this video, please consider subscribing for more captivating content. Thank you for tuning in.